So in this example, your company markets a computerized device to test a patient's mean resting heart rate. Based on the sample results, the device determines whether there is significant evidence that the patient's mean resting heart rate is greater than 100 beats per minute. If so, your company recommends that the person seeks medical attention. Now let's think about, in this case, what our null and alternative hypotheses are. Now, the device that we're looking at here that they're describing is that the device determines whether there is significant evidence that the patient's mean resting heart rate is greater than 100 beats per minute. And then if it is, then the company recommends that the person seeks medical attention. So we can put this down in our alternative hypothesis that if the mean resting heart rate is greater than 100 beats per minute, then our device will recommend that we seek medical attention. The null hypothesis in this case would be that the mean resting heart rate is equal to 100. And again, here, this would be the assumption. So, excuse me. Which error is worse for your company? Well, let's write out what this would be here if we were to fail to reject the null hypothesis when it's actually true. So if the null hypothesis were true, that that our mean resting heart rate was 100 beats per minute, then the device would not, if it fails to reject, then the device is not going to tell us to seek any medical attention. So the result here was we don't seek medical attention. And we don't need to, so it's okay. But in this case, if we made an error where we failed to reject the null hypothesis when the null hypothesis was false. So in that case, our mean resting heart rate was greater than 100, but we failed to reject the null hypothesis, and so our device didn't alert us. So we didn't wind up seeking medical attention when in fact we needed to. So what about the type 1 error in this case, where we reject the null hypothesis, but we have in this case that the null hypothesis is true? So in this kind of error, we would be told to seek medical attention because we're rejecting the null hypothesis, and since we're rejecting it, we're supporting the alternative. And so we would be told to seek medical attention when in fact we didn't need it. So in this case, this kind of error would be that we seek medical attention even though we didn't need it, versus the type 2 error where we didn't seek medical attention but we did need it. So this would be the type of error that perhaps is more grave, because the consequences of this kind of error means that somebody would not seek medical attention when they actually needed it. So versus this one, where somebody seeks medical attention when in fact they didn't necessarily need it, is not going to have any grave consequences. So the consequences of this type of error, the type 2 error here, are worse. because we see again that somebody didn't seek medical attention when in fact they should have. We will not know 100% if our conclusion of our hypothesis test is correct, but we can assign a probability to making a type 1 or type 2 error. And we generally use the letter alpha when we're talking about the probability of a type 1 error. And we use the letter beta when we're talking about the probability of a type 2 error. What we're calling the level of significance we'll assign to the probability of making a type 1 error, and so that'll be represented with the symbol alpha. The probability of making a type 1 error is the case where we're taking a sample that makes us reject our null hypothesis when in fact it's true. And one important property is that when we increase the value of alpha, in other words, if we increase the probability of a type 1 error, then the probability of the other type of error will decrease. And that can be useful in helping us choose a value for alpha. So typically, we're going to try and assign a value for alpha somewhere between 0.01 and 0.1. So on the lower end of the spectrum, we'll assign alpha a value of 0.01, and on the upper end of the spectrum, we'll assign a value of 0.10. And so depending on how serious the consequences of making a type 1 error are, we might want to choose a small alpha. For instance, if we have a serious consequence of making a type 1 error, we want to try and minimize that type of error as much as we can. So if the consequence of making a type 1 error is more serious, then we would choose a smaller value of alpha. So we would choose a value of alpha sort of at the lower end of the spectrum. And in this case, then we would have a case where making a type 2 error would be less serious. So we can sort of make that judgment whether or not it's more serious to make a type 1 or a type 2 error. And if it's more serious to make a type 1 error, then we want to choose a smaller value for alpha. If it's the other way around, however, then choosing a bigger value for alpha would be a better choice, because here, if our consequence of a type 1 error is not as serious, then it would be okay to have a higher value for alpha, in which case then it would have a smaller value for beta. So in this case, we would choose a larger value for alpha when the consequence of making a type 1 error is not as serious as the consequence of making a type 2 error. So if the consequence of making a type 2 error is more serious, then we would want to choose a higher value of alpha.